Good morning and good evening, wherever you are at. Thank you so much for joining us today. My name is Cesar Rojas. I am a product marketing manager for the Nutanix database service, and I'll be your host today. We're thrilled to have you here as part of the Nutanix database service Tech Talk series. The topic of today is copy data management and point-in-time restore for databases with NDB Time Machine. Our speakers today are Raghu Jha, Principal Product Manager for Nutanix Database Service, and Susindran Babu, Engineering Senior Manager for Nutanix Database Service. Before we start our presentation with Raghu and Susindran, we would like to understand your current level of adoption of NDB. For that, we would like for you to answer the questions on the poll that is going to be showing your screen very soon. I'm going to launch the poll right now to understand where we're at. And we're going to give you a few minutes so people are still joining this webinar to answer this poll. So please feel free to answer the three questions on the poll. The first one is, what is your interest in the Nutanix database service? The second one is, what is your familiarity with the NDB Time Machine? And the third one is, what version of NDB are you on today if you're currently on NDB? I see people that are still joining this tech talk, so we're gonna wait, a little bit, so we have as many answers as we can, so we can actually customize this presentation for you for the kind of answers that you have on this poll. So again, I'm gonna give it about 1 or 2 minutes. There's people still joining the tech talk. And once we're done with the poll, we're going to be able to move forward with the tech talk. Okay, if you're just joining, there's a poll on the screen. Please feel free to answer the questions on the screen. Thank you so much for that. So let's move forward. And Raghu, feel free to continue. Thank you so much.
Hello, everyone.
Let me say something, Raghu, I forgot to mention. If you have any questions throughout this presentation, feel free to answer, to ask your questions, and we'll be able to get back to you as we progress on the presentation here. Go ahead, Raghu. Sorry for interruption.
No worries. Thank you, Caesar. And good morning, good evening, good afternoon, wherever you're joining from. So the agenda for today's session, as Caesar just mentioned, we'll be talking about copy data management and restore using NDB time machines. So we had one session earlier that we did, session 1. So we'll do a quick recap. Based on the poll, I see that a lot of people do not know about NDB. So I'll talk a little bit about the NDB also. We'll talk about in-place recovery, restore, copy data management, that is the cloning. And we'll also understand the mechanics of how cloning and restore works. And if time permits, we'll try and do a short demo. So a quick recap of the previous session that we had and about NDB. So for those of you who don't know, NDB, Nutanix Database Service, is a database or a DBaaS platform which helps you basically manage your proprietary and open source databases. Proprietary databases like SQL Server, Oracle, and open source databases, MongoDB, Postgres, MySQL, MariaDB, so on and so forth. And for each of these databases, we allow you to provision single instances and highly available instances. That is SQL Server always on, Oracle RAC, and Postgres high availability using Petroni and HA proxy, MongoDB replica sets, MongoDB sharded clusters. So we help you provision such instances with NDB. We also help you patch these instances once you basically provision these instances with NDB. And the thing that we're going to talk about today is Time Machine, which is basically your backup and recovery capability that is offered through NDB. right? So we offer backup, we offer also to be able to restore and clone. And all of this can be done through the API, through the GUI that we offer, and also through the CLI. We also have a Kubernetes operator, Terraform provider, so you can basically integrate this with your various scripts, with your ServiceNow, and all of this, right? Since runs on NCI, right, is platform agnostic. So you basically get the same experience whether on-prem or in the cloud through NC2, right? So this is about NDB, and just reach out to your nearest sales person, and we can arrange a detailed discussion if you want to understand about NDB and all of the different use cases. So today's use case, again, I'm quickly covering the recap of what we covered last time. So we spoke about Time Machine. Time Machine again is the backup recovery capability of NDB. So when we say backup, right, so backup in NDB or Time Machine is a combination of two very important things. That these are snapshots and logs, transaction logs, right? When you talk about snapshots, these are Nutanix AOS snapshots. These are storage efficient, application consistent snapshots that we take, and we help you achieve point in time recovery, right, to the second using database transaction logs. So we basically capture snapshots and we capture logs, and a combination of this helps you get a continuous timeline or a point in time recovery timeline. And as you can see in the a small screenshot that I've put in here, right, you see a screenshot or you see a timeline like this, which can help you go back in time and restore your database or help you clone your database, right? Uh, so the Time Machine has a few more capabilities. We help you retain your snapshots and logs for a certain period. So you can have daily, weekly, monthly snapshots that you can maintain using NDB. You can also have a minimum frequency of log backups. So you can set a log backup frequency with a minimum frequency of 15 minutes. This is what we offer using NDB. We also help you replicate your backups, that these are snapshots and logs, to multiple Nutanix clusters, right? So your backups can reside on the cluster where the databases are running, or can also reside on the other clusters, or you can replicate these to the other clusters. Time Machine versus traditional backup tools, right? So Time Machine completes within few minutes because it is snapshot based. With traditional backup tools, obviously, as the database size increases, your full backup takes appropriately takes a longer time, right? Storage, again, snapshot based storage is always efficient, so we don't consume so much storage, right? And with traditional backup tools, storage grows. We talk about RTO. So all this we covered in the previous session, so I'm just touching upon, but we'll get into more detail in today's session. So RTO is very fast, right? With snapshot-based recovery, with NDB Time Machine, you can achieve recovery within minutes, but with traditional recovery, it takes very, very long. So just going over, so we also covered the architecture a little bit, right? Where the NDB UI, so once you basically fire a request, right, to capture backups. So then the NDB server or the NDB management plane, so there's the NDB server which receives the request and then passes on the request to the database server, and the DB server either takes a snapshot or and similarly captures the transaction logs. These log backups, again, are maintained on Nutanix objects. So I'm just touching upon these two slides very quickly. I think we went into more detail in our previous session, but yeah, just touching upon these at a high level. So getting into what we wanted to talk about in today's session, right? So we specifically want to talk about database restore and database cloning. So when we talk about database restore and cloning, I think the most important thing is to understand and appreciate how AOS snapshots work, right? So Susindran, I'll just pass on to Susindran. Susindran, maybe you can cover this slide.
Sure, Raghu. Thank you. Hello, everyone. So, in order to understand, how NDB takes a faster snapshot and performs a faster restore, we would like to understand, a little bit on, how the snapshot happens at the storage layer. So, this will help us appreciate, how our snapshots are much faster and our restores are, faster as well in comparison to the native backup and restore technology. So, the first diagram shows, your disk and the disk that is, blocked the blocks that is mapped to the disk. When a snapshot is taken, we have another disk that is blocked to the same set, that's mapped to the same set of blocks. And this mapping is non-editable. We will not be able to change this mapping. The contents of these blocks will never be editable. It's always read-only. When any update comes to the original disk, the update goes to a new block, or when a new write comes to the original disk, the write goes to a new block. This ensures that the existing block that is mapped by the snapshot is never changed. If you look at it, this entire operation is how the snapshot works. And since it is just a metadata mapping and metadata update, our snapshot technology is much faster than the traditional backup technology. Let's talk about a little bit on the clone aspect of it to see how your restores of the database or restores of the disks are much faster in comparison. When you request a clone to the storage layer to the snapshot, what only happens is there is a block map that happens to the existing snapshot. This is once again only a mapping for the existing block, and we are not doing additional block copy or any a copy of the data to any new block. Since no copy involved to a new block altogether, it's only redirect to the existing block. Your clones are even more faster. Now, all the base disk, the snapshot, and the clone read from the same set of blocks. Any new modification comes to the clone, it gets returned to the new block. The base snapshot from where the clone is created is never modified at all. So how do we clean up this block at this point in time? So when the snapshot gets deleted, the ownership of the blocks that has been occupied by the snapshot moves on to one of the clones. When all the clones that is accessing the block gets deleted, that's when AO's curator kicks in and deletes these blocks and reclaims the space back to the storage. This is how we are able to take a faster snapshot, and this is how we are able to take even faster clones and return the data to the customer. Yeah. Raghu?
Thanks, Susindran. So I do understand that this slide is slightly technical and goes into the depth, but I think for most of you to appreciate what comes in NDB, right, how we do restore, how we do clones, I think this is a very important slide, and that's why we put it here. So with this background, I think we can talk about. I touched upon this, right? So native data.
Hey, Raghu, sorry for interrupting. We have a question, if you don't mind to answer it now.
Okay.
Question is coming from Jason. Will clones affect performance on the database, on the base database?
Yeah. So Susindran, you want to take that?
I repeat the question, Susindran. Will clones affect performance on the base database?
Okay, I think Susindran is on mute, but I'll
Can
try
answer the
and-
question. Hi,
Yeah.
my name is Barak Bidu. Uh, the way we take snapshots, because we do a copy on write, when we do take a snapshot and or a clone, what generally happens is the performance is more or less during the uh, operation of clone or snapshot, there is no impact to performance. It's a extremely short, in the order of microseconds, milliseconds operation of creating the new clone and a new snapshot. Subsequently, like Susindran mentioned, the new writes go to um, the leaf. Now, in terms of performance impact, um, if when we do clones from the same base, the performance is not impacted because it's think about it as n different branches for each of the clones. There's no impact on the performance. When you do to take a snapshot, if the snapshot chain becomes extremely long, which is you're taking like snapshots of the same entity for say hundreds of days or hundreds of um, uh, chain depth, that's when the performance could see an impact because of the scattering of the metadata. But again, NDB ensures through its operation that this chain never grows that long. I hope that answers the question. So in short, the performance impact on a clone is none. The performance impact on extremely long snapshot chains, uh, also known as take a lot of snapshots. When they talk about hundreds of snapshots, there will be an impact. But NDB ensures that that never ever happens.
Thanks, Bharat. Caesar, do we have any more questions or we can go ahead?
I think I have a follow-up question here, but I think what has been answered. No performance impact on the source databases.
Yeah. No,
Yeah.
no performance impact on the source databases. Yes.
Thanks.
Okay. So going ahead, right? So we spoke about this a little bit when we talk about native database restore technologies like SQL Server Backup Restore, MySQL Dump, or Postgres PG Restore, Oracle RMAN. So all of these tools, right? Typically, as the database size increases, right, the backup time increases and also the restore time increases, right? And this slows down further, right, with network overhead, with the compute limits, like type of disk, whether it's a HDD or flash, and index rebuilding takes a lot of time, right? And long time if you have compressed backups to decompress those. So all of these things take a lot of time, right? And typically native database restore technologies take hours, right? So as the database size increases, so just to give you an example, a 14 terabyte database would typically take uh, like more than 5 6 hours, up to 10 14 hours, right? So but with NDB, right, so the size of the database doesn't matter as much, right? Because there's no new data that is read or written, right? As the snapshot is taken, all of the data blocks are frozen, and there's no change that can be done to the data. So there is I mean, once the snapshot is captured, we basically let you use your NDB time machine. We show you your recoverability view, and then you can do your restore. And once your restore is also done, right, as Susinan mentioned, mostly metadata related changes. So your restore typically completes within a few minutes. Uh, I know this slide has a lot of information, but I just want you to focus on what I have highlighted here. So Wells Fargo, when they were evaluating NDB, so they did a test, right? So they could recover a 40 terabyte database in 8 minutes. With their traditional technology that they were previously using, it took about 60 hours, and even after that, the restore did not complete. So just highlighting that very important information, right? So as we go ahead, just to talk about clones, right? So when we talk about NDB clones, as we spoke about, right? When you create a clone database, right, from the source, each of the clone database is a 0 byte clone, right? So let's assume I create a three clones here, right? One dev test UAT clone. So three clones if I create with traditional technologies, right? Each clone is equivalent to the source, right? Equivalent in size. And if I have to create three clones plus the source, it's about 40 terabytes of total storage. And with NDB, since it's 0 byte clones, you can basically have less storage, right? So up to 75% less storage, right? So this again, I think there are some caveats here, but I think we can cover that at a later point in time. So, okay, going ahead. Um, I think this touches upon a little bit, I think, based on what Jason mentioned. But if you are doubtful about this, right, that if you don't want to basically have you don't want to create a lot of clone databases on the cluster where your source is running, right? So you can replicate your NDB backup using the time machine to an alternate cluster, and using your the NDB global time machine that is available on different clusters, you can create multiple clones on the alternate cluster or a non-production cluster. So this is a very common use case that is used by a lot of our customers, right? So just basically summarizing from a backup recovery and copy data management. So backup recovery, when we talk about it, basically the RTO and RPO is very low with NDB, right? Since it is snapshot based and the transaction logs that we apply, you can take up to a minimum of 15 minutes, right? So the RTO is very fast, and we also offer a RPO 15 minutes. When we talk about you can recover from like data corruption events or from disasters, right? And you can use NDB. It makes sure, because the snapshots would always be available, you can replicate your snapshots and logs to alternate clusters. So even if your cluster goes down, you can still recover from your alternate cluster. From a cloning perspective, I just spoke about zero byte clones, right? So a huge storage savings using NDB's zero byte clones. I just spoke about where you can replicate your backups to alternate clusters. And if you want to run like heavy analytics, reporting, machine learning kind of algorithms on the databases, you can use like non-production databases or reporting databases that you create and manage that using NDB. Dev test, performance testing, again, another other very popular use cases for cloning, right? Which people use NDB and derive great value in. Audit and compliance is another use case. Just to give you an example, there are surprise audits that happen in India. RBI does surprise audits, right? And when audits happen, they ask for databases, right? So you can spin up your clone databases, run your masking algorithms, you can run your scripts, make sure it is sanitized, and then you give your clones to the basically your auditors or whoever has come, right, from the audit team. So just reinforcing or just reiterating the use cases that people derive great value from using the NDB time machines. Now we'll get into a little bit under the hood, right, of how basically copy data management or cloning works and how refresh clone works, how recovery works. So I'll hand it over to Susindran and we can quickly cover these slides.
Thank you, Raghu. So I'll be walking over three workflows now. One is how we perform the clone operation. The second workflow would be how we do the refresh clone operation, and third workflow would be how we perform the in-place restore operation. So let's talk about how we do the clone database workflow. User submits a clone operation, a clone with CreateDB server. The agent pulls the work and it orchestrates the entire operation. As part of the first step of this operation, agent would create a DB server VM, a dummy DB server VM, and it would attach the software disks from the snapshot that we already have. So we have a VM and the software disks, like your OS disk, and the database instance where it is running. Those disks will be cloned from the software snapshot and it will be attached to the VM, and the VM will be booted. Now, when the VM gets booted, we have the software instance already running. Once the software instance is running, we attach the clone disks from the data snapshots. The data snapshot would contain the disks of the database. So here we are attaching the disks of the database to the DB server VM, and we mount these database at the same location where your source instance is expecting the database disks to be on. Once we attach the disk and we mount it on the same location, we start the database instance, which would in turn start the database, and then it will bring the database online. In order, this flow depicts the clone operation from snapshot. In addition to that, if you want to apply logs on top of this database, we pull the logs from the object store, we present it in a temporary disk on the DB server VM, and when the database instance starts or when the recovery happens, we point to the database instance to this temporary disk where the logs are present. And when the database starts, all these logs will be applied. This will bring your database to up to state by applying all the logs. This way, we are able to provision or create the clone operation, create the clone database from the snapshot that we had taken. And as said before, this clone operation is very faster because the disks that we created are only references to the snapshot. And hence, this operation completes much faster. Moving on, I'll talk about the next operation, which is the refresh clone operation. So we have created a clone workflow. So primarily, the clone workflows are created or clone databases are created for the customer to do dev testing and audits and all the other functionalities. What customer also frequently ask is this particular clone should get refreshed based on the data that is getting changed from the source database. So usually customers configure a refresh schedule every day, as in every day the clone database should get refreshed from the data that we have on the source database. Now, as per the schedule, we create a schedule to run this particular refresh clone operation. When the schedule kicks in, an API request is submitted. The DB server VM, which runs the orchestration, pulls the work to do the refresh clone workflow. As part of the first step, what we do is we unmount the clone database and we unmount the disks of the clone database. Once we unmount it, we look out for the latest snapshot that is taken on the source database, create the cloned disk from the latest snapshot, attach the clone disk to the DB server VM, and bring up the database. So this way, once again, the attaching of the clone disk, creating the clone disk and attaching to the clone disk of the VM is much faster, very, very faster. Like I said, it's only like metadata mapping. We get to the latest data from the latest snapshot. And once again, we apply the logs from the bucket. We pull the logs, all the latest logs, keep it in the temp disk, and we start the instance. And that instance would apply all the logs and bring the database to the latest state. This workflow happens on everyday basis, or the schedule can be configured by the customer. And whenever the schedule is configured, we refresh this clone database from your source database. I'll move on to the next workflow, which is in-place restore. Your in-place restore is very much similar to the refresh clone workflow. Here, the only difference that we see is there is no clone disk that is attached to the VM. Instead, they are the source disks. So as part of the restore workflow, the same operation first detaches, brings the database offline, detaches the source disk, attaches the cloned disks from the snapshot that we had taken to which we want to restore. After attaching the clone disk, we once again pull the logs from the bucket. If we are going to do a PIT or restore, we'll download the logs from the bucket, keep it in a temporary disk, and start our database. When we start the database, the logs that is present in the temporary disk are applied on the database, and then latest data is presented to the customer. This is how we are able to achieve a faster RTO to the customer by restoring the database to the latest point in time.
We do have a question that haven't been answered on the screen. It's coming from Jason. Another follow-up to performance on the comment that writes are always written to new block. What about reads? If you have a read heavy workload on a clone, considering it is the same storage block, couldn't that create contention? Anyone wants to take that one?
You want to take it, or you want to answer it on the chat?
Is that to me?
Yeah, I said there's a question from Jason in the chat around read performance when the same source block is used by a lot of clones and the source, right?
So yeah, I just want to clarify. When we do clones, there are no long chains, right? Think about it, clone as like one root with many different branches. There is no performance impact at all at that point. And I can give a little bit of the history behind it, coming from the storage side of Nutanix. When Nutanix started off, we saw a lot of traction in the VDI world, the virtual desktop infrastructure. And one of the most common operations there is to take one gold image and create thousands, sometimes tens of thousands of copies. And each of these are given as a virtual desktop for the customer. Now, the core secret sauce of a storage system is to make sure that at this scale, we are very and highly performant. So this carrying over this technology for our databases too in NDB, the clones, even with a large fan out from one image of clones, there is no performance impact. I just want to be very clarify that. The only place where I talked about potentially a performance impact, Jason, is when we take a lot of snapshots. And when I say a lot of snapshots, like I said, hundreds of snapshots, which we don't do, right? Like NDB ensures that we never take hundreds of snapshots with our time machine policies and so on. We capture logs that was explained earlier about each point in time recovery, how we do that. And we take few snapshots. But like, as a customer, we ensure that customers don't worry about the performance impact, or they won't see the performance impact, either in the clone case or in the snapshot case.
Yeah, Bharat, I think the specific question is that if there's a source running on a particular cluster and we
Yeah.
create a clones, we said that these are 0 byte clones, and these clones have a lot of read-heavy workloads running in parallel, right? So that let's assume they create in parallel a lot of clones, and all of these clones are running like continuous read-heavy analytics kind of workloads. So is there going to be any impact on the source here is what I think Jason's
So
primary question. Because the
no, the
source log
source, the source won't see hit on performance. Now, the way we also do it is that all of these clones could be running on different nodes in the same cluster. Now, the source VM is database is running on a particular node of the cluster. We do have the metadata that's globally available across all the nodes. The source will continue to get from that metadata that's also cached in that particular node. So there won't be a performance impact on the source at all. The rest of the clones, wherever they're running in the cluster on any of the nodes, there is also the metadata that starts spreading, like any of that gets distributed for the metadata associated with the base copy. That metadata also starts getting distributed and cached across the cluster, across different nodes. The writes that these clones do, of course, will go to that particular local node. So we have designed the underlying storage system to handle these conditions without performance impact, especially no performance impact on the source database we have.
Okay, cool. Thanks for clarifying, Bharat. Caesar, are we good? Can I quickly do
Yeah,
a
there are more questions, but let's move into the demo and then we can answer some questions. So
sure. So this is the login page for NDB. I'm just covering NDB and the time machine. So I already have one database. So this is a relatively fresh setup. So I have one database, one Postgres single instance database running, right? And as you can see, details around the database, right? So this single instance database has been created using our out-of-box profile. And there is a time machine associated with the database, right? So every time a database is created, a time machine gets associated with the database. So if we go to the time machine, right, since this is newly created, as I was showing in the earlier screenshot as well, you start seeing a continuous timeline, and based on your retention period that you have set up, right, you will continue seeing the calendar view, and this is because it's been created today. So you are seeing a continuous timeline from the time the database was created and the log catch-up has started, or the log backup has started. So I will try and attempt a restore and a clone. I have also done a restore earlier today, but yeah, just letting you know how it works. So let's first cover cloning, right? So when we try to create a clone, so I chose a point in time, right, from the timeline, right? I can create a clone. I can recalibrate my time. So let's say I want it from 6:36, right, today. And I have just one cluster. So on this particular cluster, right? So I've chosen the point in time, and I can use, so once I create this, I get two options: either to create a completely new database server VM, or use my pre-authorized database server VM that I've already registered with NDB or already created with NDB. So I have a database server that I have already created, so I'll just use this, right? But you can always create a new database server for the particular clone, right? And provide some minimal information that is required, right? So I will use an authorized database server VM, and I will Yeah, so this is. So I think there was some question around the refresh of the clones, and so you can schedule a data refresh. So you can say that refresh my clone every day at a particular point in time, or like every 2 days, so on and so forth. So you can schedule a data refresh for your clones. You can also set up a removal schedule for your clones. So if you want to retain your clones for about 20, 30 days, right? Or for like 3, 4 days. So just set up a removal schedule, right? And delete the database clone from the VM, right? So this is what you can do, right? So I will not set up this, right? And I will just do a create clone. So as you can see, the operation has started, right? And you can start seeing, right, the progress, right? So there are multiple steps in creating of a clone. It will take a few minutes, so I can just show you an earlier clone that I created. So this completed in about 4.5 minutes that I created earlier today, right? So just to give you an example of how quickly the clone database can be created. So similarly, I'll go back to the time machine and try and do an in-place restore also of the database, right? So here is my timeline, right? I can go back and I can basically restore source database, right? Try and attempt to restore. Yeah. So yeah, this is the point in time, right? So this is a Postgres database, so you can uh, so if there are additional logs, right, so you can just check these also, right, and make sure that any additional logs have been captured or not. So let's assume that the last log catch-up was done maybe 30 minutes back. So you want to just run a log backup on demand, right? Make sure that you're caught up to the latest time. So right. So choose that point in time and then do a restore of the database. This is the name of the database, just confirming that you want to do the restore, right? So a restore operation has been kicked off. So just to let you know, right? So similarly, we have these different steps that you can see. You can track the progress of your restore. So earlier today, I had run a restore. So to just let you know, right? Just to give you an idea. So this took about 7 minutes and 35 seconds to restore. And so the size of the database does not matter as much as we spoke about and we said, right? The snapshot based restore typically happens very fast, right? But so we first restore to the snapshot and then apply the logs. So that takes slightly longer, right? So this is about how NDB helps you manage your database, and you can go to your time machine and you can, so just to let you know of the different options that we offer, right? So yeah, so you can create a clone, you can restore, you can authorize database server VMs similar to what I did, right? You can pre-authorize your database server VMs where you want to create clones or where, right? So you can already do that. You can run an on-demand log catch-up, right, or a log backup. So let's assume that your last log backup ran like 1, 2 hours back, but you want to basically make sure that your logs are caught up. So you can run an on-demand log catch-up. You can also take an on-demand snapshot, right, which we call as manual snapshots. You can pause your database. You can resume your you can pause your time machine and you can resume your time machine. And you can update your time machine also. When I say update your time machine, you can also make sure that your if you want to change your retention period, you want to change your log backup frequencies, you want to make sure that you want to maintain your snapshots for longer, or you want to just reduce the snapshot usage. So all of those things you can do using your update. There are a few things here that those are properties of the time machine. I think we covered last time, but just to let you know, so you can see which all are your snapshots that you've created. Using database access or data access management, you can make sure that you replicate your backups to alternate clusters. I just have one cluster here, so if I had more clusters, I can replicate my backups to an alternate cluster, right? So this is primarily about time machines, right? And I think we have, yeah, so the clone is almost done. It's about at 95%, right? It's about 2 minutes, 35 seconds. So this should complete in a minute or two. and the restore will take another 3-4 minutes. I'll not make everyone wait, but this is at a high level time machine cloning and restore and how simple it is using the UI. Similarly, you can do using the API and the CLI, NDB CLI that we offer. So this is the demo. Yeah, I think we're almost done. I think, yep, I think it's time for questions, if any.
If you have any questions, please feel free to ask them on the Q&A session of this tech talk. By clicking the button, QA button on your screen, and feel free to ask your questions. We've been answering questions throughout this tech talk, but feel free to ask questions. I think we have one already. I think it has been answered. Yeah, again, if you have any questions, feel free to ask your questions in the Q&A. Let's wait a minute for questions and.
Yeah, I know the session had a lot of elements, a lot of moving parts. We spoke about snapshots, we spoke about data blocks, we spoke about NDB server, we spoke about a lot of things, right? For those of you who are attending this session for the first time or are hearing about NDB, I think this was maybe an overload, I would say. But I think this is mainly for you to appreciate the complexities that are there behind the product. So if you have any questions, please reach out to the nearest Nutanix salesperson or the sales engineer whom you're in touch with, or you could always reach out to the NDB PM if you are already connected with the NDB PM. So, yeah.
Yeah, we do have two questions. One is actually it's on the chat instead of the Q&A, but it says the cloning task actually clone the entire VM or the database only.
Yeah, we do both actually. We perform the clone of the VM as well as the database. And there is also a workflow where we can perform the clone operation on an existing VM too.
Awesome. Thanks for that. Next question is, I'm new to NDB, need to know what is the use of NDB provisioning database.
So just to maybe understand the question clearly, I think this is about NDB provisioning and the provisioning functionality that we offer in NDB. Srinivas, is that the question that you're asking? Just to clarify the question. Yes.
Yes.
Okay. Great. So yeah. So NDB provisioning, when we talk about provisioning, right? NDB offers provisioning, as I said, for all of your proprietary and your open source databases, right? When we say proprietary, SQL Server, Oracle, and all of your open source databases, Postgres, MongoDB, MySQL, MariaDB, right? And for all of these databases, we offer provisioning of your standalone instances and your highly available instances. Highly available instances, when we talk about, so Postgres HA using Patroni and HA proxy, SQL Server always on FCI, Oracle RAC, right? And so on and so forth. So, and MongoDB sharded clusters, MongoDB replica set. So we offer provisioning. When we say we offer provisioning, we offer provisioning automation, right? So I think we'll definitely have a more detailed tech talk around how provisioning works. But at a high level, NDB works with a concept called different profiles, right, or software profiles. And these software profiles are basically snapshots of your OS and your database or software. And using this, we help you basically automate your provisioning process. Typically, why people prefer provisioning with NDB is because there has been a lot of research that has been done by database experts to make sure that databases running on Nutanix work in a very, very efficient way when they are provisioned using NDB. When I say work in an efficient way, so there are some best practices that have been created by our solution architecture team or solution engineering team. and they have basically created guidelines around what should be the database configuration and how should the database be provisioned on Nutanix infrastructure for them to work for them to be highly performant, right? So NDB basically helps you manage these databases or provision these databases using the best practices that have been created for the particular database and working with Nutanix infrastructure. So the best of databases, best of infrastructure in a combination, right? So NDB basically helps you provision databases so that these databases are performant. And how they work, I think it's a longer topic. So, but I just try to cover in a short gist, right? So I hope I answered your question, Srinivas. So that is at a high level what provisioning does. Uh,
Yeah, we have another question. What exactly captures in the database? Why? Because we are seeing the database in our SQL instance.
do you want to unmute Srinivas? Maybe we can directly discuss.
Kaz, can you mute this person that is asking a question right now? Okay.
Do you want me to unmute?
Yeah, just that person that is asking the question.
Srinivas, would you be okay to join the panel and discuss? Or okay, I think he's willing to join to be unmuted. So can you unmute, Cause?
If it's not possible, we can
Uh,
potentially.
There we go.
Okay.
okay. Srinivas, can you ask a question?
I
Okay.
have it set as fucking permitted. So
He might have an audio issue. Okay. He's having an audio issue. So let's
No
keep
worries.
communicating with him.
On the chat, yeah. Maybe Srinivas, you can provide us more details around what you are seeing and what is the issues you're facing. Maybe so Simran can, yeah. He said he'll drop an email. Sure, Srinivas. Yeah.
Okay. Thank you. Yeah, we take it offline. So if you have any questions, feel free to use the Q&A button, please. Or other than the conversation with Srinivas, that's gonna happen offline. I don't see any other questions at this time. Let's give it another minute, and if we don't have any other questions, we'll conclude the tech talk. Okay, let's give it another minute, and we don't hear from anybody, we can conclude. Okay, I don't think we're getting any other questions. We've been answering questions throughout the tech talk. We really appreciate, all those questions. We are trying to be as interactive as possible in these tech talks. And please be aware that we're going to be actually answering questions also offline. And we're also going to be posting these tech talks on YouTube. So please stay tuned for the next tech talks. We have a full, roadmap of tech talks that are happening in this year, and we're more than welcome to have you there and answer all your questions. But for now, we're gonna let this one finish, and thank you so much for your time. Appreciate it, and thank you so much, Raghu, Sindra, and Bharat.
Thank you, everyone. Thank you so much.
Thank you, everyone.